Welcome to EDU World Space.
In this question, we have to compare the wavelength of an electron and a proton, given that both of these masses have the same non-relativistic kinetic energy. So the expression for non-relativistic kinetic energy is given by p square over 2m. And so my momentum will be equal to then 2 times the kinetic energy and root over of that. So this is a little bit messy, so let me make the bracket clear. Okay, yeah. So this is the momentum in terms of the kinetic energy of the particle. Now, using equation 27(8), we get that the wavelength of a particle or the de Broglie wavelength is equal to the Planck constant over momentum. Now, for a non-relativistic particle, P is basically given by this expression. So I'll just write it over here. Now, we are given that the kinetic energy of the electron is equal to the kinetic energy of the proton. So let's take a ratio of the wavelength of the two particles. So using this equation, of course. So then my lambda p over lambda e will be equal to then h over 2mp kinetic energy of electron over h over 2me kinetic energy. Sorry, this is kinetic energy proton, this is kinetic energy of electron, but doesn't matter because they both are given to be equal. So this then reduces to me over mp whole root over. Now we just need to prove that the wavelength of a proton is shorter than the wavelength of electron. So we don't need to calculate this value. We can simply see from here that the mass of the electron is less than the mass of the proton. So this value is then less than 1. Or we can say that lambda p over lambda e is less than 1. Or lambda p is less than lambda e, which means that proton has a shorter wavelength than electron.